Hello friends, I'm Ram Lakshmanan. So I'm the architect of Ycrash. So in this talk, we are going to be discussing about the advantages, the benefits that you can get from using the virtual threads in your application, right? In our earlier talks, we spoke about the architecture of the virtual threads and the pitfalls, what you want to be looking at avoiding, and then how to create a virtual threads, right? I'm sharing all those links in this talk. Now we'll get started to learn what are the advantages of virtual threads, right? So friends, one of the main advantage that what you get by using the virtual thread is reduction in the memory consumption, right? How virtual thread is going to reduce my memory consumption? To do that, first of all, we need to understand the life cycle of a typical thread, right? Most of the threads follow this convention, but there are exceptions as well, right? But significant of architectures follow this convention. See, this is that architecture, right? Here you can see that black arrow indicates it's a new customer request that is coming to our application. When a new customer request comes to our application, at the very forefront, there is this application server thread pool, right? Which has a pool of threads. So this red arrow indicates in the diagram as a thread. When a new request comes, the thread picks up the customer request. It executes our application logic, and then it makes a backend call. Now, when it makes a backend call, it has to wait for the response from the backend system of records. It can take sometimes milliseconds, few seconds, right? It has to wait for time period. Once the response comes back, then it's going to process the response, and then it's going to send back the response to the customer, and then it goes back to the thread pool and then waits there for until the next request comes. If you see what's happening, a thread is first waiting in the thread pool for new request to come, and now it is waiting for the backend system to respond, and now it goes back to the thread pool and waits there for once again for new request comes. And sometimes when it's executing the code, sometimes the thread can be blocked. Sometimes the developer may put it on a wait state, and then it's going to wait. So in a typical life cycle of a thread, it waits for a long period. Then it actually executes the real task. It waits for a long period. Whenever a thread executes, right? See, not to appreciate this one, I strongly recommend you to watch the Java virtual thread architecture video clip, which is given in the description, because you need to understand that before you want to watch this one, right? Learn the benefits of it. Okay. See, when a thread only in the virtual thread architecture, only when it is executing some lines of code, when it's executing something, it is assigned to a carrier thread, which is a platform thread, which underlying uses an operating system. That platform thread is an expensive object. It's not cheap, right? It depends. Somewhere it's going to be like, for typically, it varies. The JVM default of a thread stack size varies by your operating system and the JVM, but typically if it's going to be 512 kilobyte, right? That's what we can take it as. Sometimes it can be on 1 MB. So it's an expensive object, right? So in the classic threads or in the platform threads, what happens is, even when the thread is not executing any lines of code, and even when it's waiting, the underlying operating system thread is assigned to this virtual thread, which is a very expensive object, right? So it is even when it's waiting, that the threads are assigned to it, so it occupies memory. Whereas in this virtual thread, when the thread is waiting, that it's not assigned to an operating system thread, rather it's just stored in the Java heap as a chunk objects, which is occupies very, very minuscule, only few bytes. Whereas here it is megabytes or few hundred kilobytes, right? Which is such a sizable difference, right? So when you move to this virtual threads, you can see a reduction in your memory consumption, especially if your application has a thread intensive. So if you have a lot of threads, then if you move to this virtual thread architecture, then your memory consumption will get reduced. But if you're just having a very small number of threads, moving to virtual thread you may not see a sizable difference in your memory consumption. Friends, the next benefit that what we get by moving to this virtual threads is your application availability can get better, right? Look at this. So this is the architecture what we saw earlier, right? a typical architecture of most applications. The black arrow indicates these are new customer requests which is coming in. When a new customer request comes, a thread from the thread pool picks up that job and makes a backend call. Right? Let's look at this scenario, which is very common. What if your backend system slows down? Say its typical response time is in milliseconds, but now because it is having an outage and it is slowing down and it's responding to you back in few seconds or several seconds now, which used to respond in few milliseconds. Now it has become several seconds. In that circumstance, what's going to happen? All our threads are going to be going and then they're going to be stuck waiting for the response from the backend system of record. If the threads are getting stuck here, then the forefront, the servlet thread pool, which we are configured, is a finite resource. If it runs out of the threads and if new request starts to come in, there are no more threads available here in the front to process the request. Right? In that circumstance, your application will have an outage. So even if your application may be talking with multiple system of records, even if one system of record has a slows down, you can have potentially it can trigger your application can become unavailable. Right? So, and it will be quite possible that the system of record which is not responding may be not a mission critical system of record, but it can be just, even if you don't get the data from there, still your customer may be okay. But because of this architectural dependency, it causes the outage. My entire application will become unavailable. Now, friends, think about if you're in a virtual thread architecture, right? Here, this servlet thread pool, if I'm going to configure as a virtual threads, I can keep creating infinite number of virtual threads, right? I can keep on creating more threads. So it keeps on making calls to say, so if this system of record is now getting stuck, all the threads which goes here are getting stuck, which is fine, right? Because the virtual threads, once it is waiting, it's not going to be taking up the expensive operating system thread. It just moves to memory and just sitting as an object in my heap, which occupies very minuscule memory. So here I can keep on creating more threads and which can make calls to other active system of records. And then I can keep sending response back. So it can improve your application availability. Okay, friends, another benefit which is cited is it will improve your application throughput, right? It's not true in most applications, but in certain see, what is throughput? Throughput is number of requests that I can process in a unit of time. It is in per second, right? I'm processing 1,000 requests per second or 500 requests per second. That is what throughput is. So the throughput is directly proportional to the number of threads you have, application thread. So if you have less number of threads, that means I can only process less requests. But if you have more threads, I can process more requests, right? So virtual thread gives you an infinite capability. You can create infinite number of, not infinite, but at least several thousands or millions of threads you can create. So automatically I can process more requests, right? So throughput goes high. And I also seen, not always, in few applications, your thread gets saturated before your other compute resources, such as CPU, memory, network, and storage before that your thread count, the threads get saturated. So when you use virtual thread, you can break that limit. So you can have more threads, so you can process more requests, so your throughput can get better. Okay. Now going to the fourth advantage, that is, when you use virtual threads, you can reduce the impact of out-of-memory error unable to create new native thread. That is, you cannot eliminate, but you can reduce it, right? Why is that, right, friends? See, friends, when do we get, first of all, we want to understand, when do we get this out-of-memory error unable to create new native thread? When do we get this? We get this error under two circumstances. Circumstance number one is, see, if you see on the virtual thread architecture, as we discussed earlier, the threads are created in this native region, or it's also called as others region. The threads are created in this native region, right? And this native region, or it's called as others in this slide, others region, it can grow until what is your capacity of your RAM. It can grow until what is your capacity of the RAM, right? Or what you allocated for the container, the memory, what you allocated as a memory for a container, can grow till that limit. See, if it reaches that max RAM capacity limit, then you will start to get out of memory error. Right? That is one reason why you'll get this out of memory error, unable to create new native thread. The second reason why you are going to get this out of memory error, unable to create new native thread is operating system at the kernel level, it's going to assign a permissible limit that on a number of threads a particular process can create. It may set 512 threads, 1024 threads. There is a limit the kernel sets. And when you go beyond that limit, that's when you're also going to get this out of memory error, unable to create new native thread error, right? Say, a lot of time this happens because, say, I'm creating threads. I can keep on creating threads. And when it goes beyond any of these two limits, I'm going to be getting this error. But especially, friends, if you look in the virtual thread architecture, a thread, right, when it's not executing any real task, it just stored as an object in the Java heap memory, right? When it does that, it's not actually using a thread, just an object. So say for some reason, my application has some issues and I keep on creating a lot of threads and they are waiting. In the earlier, if I'm going to use my platform threads, then I'm going to run into this out of memory error, unable to create new native thread, right? Whereas now, what will happen if I keep on creating threads, and most of the time threads we saw it's going to be waiting, but now they're just going to be they will be resident of as an object in the heap memory, right? So they won't take up the thread. So I won't breach that limit, unlike I would have done in the platform thread. So when you go to this virtual thread, then number of times you're going to encounter this out of memory error, unable to create new native thread, will go down. Next benefit, what you get by going to this virtual thread is your code quality can get better. See, friends, because of this inefficiency in the thread, this framework, like there is a reactive framework and there's an asynchronous programming model framework. Right? Those are in existence, right? So people use it, right? Say, for example, if you're using a netty library, right, that falls into this kind of a programming model, right? So what happens is in this programming model, whenever a thread, how it would typically work in the, if I'm going to use this reactive programming model or asynchronous programming model, let's go back to this diagram. Now, when a request comes, right, a thread picks up, and then it will make a call to the backend system of record, and then the thread in this program, it's not going to wait for the response. It just comes back. Now, when the backend system responds back to me, at that point, a different thread, not the same thread which went and made a call, is not going to wait. It's going to come back. And now a different thread is going to pick up that job and come back from the database. The different thread is going to execute the code, and then it's going to send back the response. See, now if you see what has happened, okay, this conserves the thread, right? So my thread doesn't have to wait. So my thread can keep on executing, right? Which is good. They're conserving the thread usage. But this type of reactive or this asynchronous programming model has one consequence, which is my code quality gets a little bit more cluttered. Why is that? Because in the earlier state, or in the original programming model, when I make a call, I'm making a call, and then I'm waiting for the response, and then I write the code below. So I might have written the code in a sequential. It's written in a sequential manner. Whereas in this asynchronous programming model or this reactive programming model, the code to make a call is going to be in one method. And the response, once it comes back, that's going to be a different method. So it's going to be in two different parts of application. So say, suppose if you want to put some exception handling across my entire database, entire backend call, or I want to put some condition across the entire call, those all gets tricky to do. And also it's at different parts. So debugging also becomes a little bit more trickier. Whereas now in this approach, because I can virtually create any number of threads, right? So I can write it sequentially. The code is much more easier to maintain, read, and manage, right? But at the same time, I get the benefits of using an optimal number of threads. So that's another benefit that I get by using this virtual threads, right? And the sixth benefit is to move from the platform threads to virtual threads. It is all the API that works with platform threads works here as well. But there is some pitfalls what you want to be watching that I'm talking about it in a different video clip. I'll share the description. I'll share that link in the description. So all the APIs that works for the platform threads works with the virtual threads as well. So there's no code refactoring, nothing I need to do. Just how I launch the thread, right? Instead of launching a platform thread, I need to launch a virtual thread. That's the only thing I had to change. It's a very, very small change, and sometimes it's done as a configuration. Right? How do we create virtual threads? I've spoken about in a different video clip. We will share it in the description. Right? Okay, friends. So this comes to the end of our discussion. So thank you everyone for watching this clip. Okay, we'll connect back with you at another interesting session. Thank you.